All right, so, yes, we're going over the exam. Question number 1. You have n equals 1, n squared minus 1. What is that? N squared plus n plus 1, right? So this one is, this one diverges because of the divergence test. That diverges because if you look at the sequence, which in this case is these terms, you can see that as you move on down the series, that which you're adding to the cumulative sum is not getting small, right? As n gets huge, this gets closer and closer to 1. And in order for the series to even have a chance of converging, that must be, it would have to at least be 0.
I got that one.
We know that there are sequences for which it goes to something which does go to 0 and doesn't converge, but at the very least it has to be, the sequence has to go to 0. So this diverges, by the divergence test.
So I got full credit on that one, right?
Yeah, the way I did it, okay, there was 4 parts. I got 6 points for each one, and 1 point for free, so that adds up to 25. All right. Second one, we have the sum in one of n plus 1 over the same denominator. And in this case, this is a case where in actual terms, the sequence itself, right? He says, actually, it actually does go to 0. So the divergence test doesn't really tell us that it diverges. It just says it could potentially converge, right? But yeah, I think when I see this, what I'm thinking in my mind is that n plus 1 over n squared plus n plus 1. If you kind of ignore the terms of lesser degree, it's kind of like n over n squared, also known as 1 over n. And we know that this diverges.
Harmonic series.
Yeah.
I wrote that one too. I wrote all of it.
But technically, this is not a harmonic series.
Yeah, you're just comparing it.
Yeah, exactly. And we have 2 types of comparison tests. You really, to get full credit, you really need to be clear which one you're using, and you got to use it correctly, right? There's the comparison test, then there's the limit comparison test.
So this one, you should have said the limit.
Yeah, I would use the limit comparison test here, because like we discussed before,
Right.
it's not really clear whether this is greater than or less than 1 over n, at least not in an immediate way.
Right.
So, and honestly, like, I didn't say this before, but I feel like anything that the comparison test can do, the limit comparison test can do better. You know what I mean? So yeah, so I would be considering the limit of the series in question, or rather the sequence in question, all over what I suspect the behavior of this is going to be very similar to the behavior of the series, the harmonic series. And that's why, so that which I'm comparing it to, that which I do know the answer to, is going on the bottom. And this limit is the same thing times n over 1, also known as, let's see here, what we got, n squared plus n over n squared plus n plus 1. And that goes to 1. And when the limit is finite, basically anything other than 0 or infinity, then that's going to be, that means that the behavior of this function can be identical to the behavior of that one. So, because this diverges, this diverges. Also, so the next one looks almost identical to the last one that I wrote, only difference being that it's alternating. Now, we have an alternating series test which says that if these terms go to the zero, right, in general, I can't say it converges, but if it's an alternating series with those things going to zero, then yeah, it converges. So all you have to do is just show that the positive part that isn't alternating, goes to zero. And that's a simple exercise from differential calculus. So because that goes to zero, and because it's alternating, this series converges by the alternating series test. So yeah, maybe I should mention that. Alternating series test, or AST for short. Some teachers, when you take this class, they're going to be really rigid about explicitly saying which test they're using. You know, I shouldn't have to guess which one they're using. You know what I mean? So like right here, you would have wanted to say this diverges by the divergence test, that's PT, right?
Yeah, I remember that one.
And this one is by
Limit comparison.
limit comparison test. And the fourth part of that one, so this n plus 1 n cubed plus n squared plus n plus 1. I wasn't really feeling very creative when I created these problems. You know? It's just logical.
Just a hot, one higher degree.
Yeah. Yeah, so the logic here is very similar to the logic used here. Right? So
Limit comparison.
yeah, I can see that this right here, so this formula behaves quite similarly to this, also known as.
1 over s squared.
And I know that this sum converges by the P series test, right? This is the P series, and that one converges by the P test. This is not a P series. It behaves very similar to that one, but technically it's not a P series. So I wouldn't say that this converges by the P series test. That would be a mistake. Right? This one does. And so I'm kind of doing that P series test in combination, right, with, we'll just use this one again, the limit comparison test. So since the limit of n plus 1 over n cubed plus n squared plus n plus 1, I think it's a good idea to compare it to that, you know. And if you do the algebra, it's going to end up looking like n cubed plus n squared all over n cubed plus n squared plus n plus 1, and that's 1. So again, because I know this converges, then this one must do the same thing. So this is by the P series test. But in the end, I can say that this converges by the limit comparison. There you have it. So I think that's a decent survey of the various tests that we use for sequences.